Hello everyone, this is Sixia ZHANG, and my topic is on investigating the robustness of dense retrieval on queries with typos. So our focus is on the query with typos. So why we want to research on this topic? Because like in our daily life, we may type something wrong on the query, but we still want to get desired answer from the searching engines. Like, for example, we typed dense with C instead of S, but we still get it maybe expected answer from the Google searching engine. So this is kind of a really good performance on the algorithm. So what kind of algorithm behind it is that the retrieval algorithm. So there are two kinds of retrievers. One is the sparse retriever, such as PM25. It put exactly word on the query and then trying to match it with the related passages and return the most similar passages with the queries. But in this situation, if we got some typos in the queries, it will performance really bad. So in this situation, the dense retriever will performance better since the similar words may have the same symbol during the algorithm training, and it will be treated as the same. So the example for the dense retriever are RapBERT and MonoBERT, which is the dense retriever and the BERT re-ranker that we used in the original pipelines. So these two, they trying to get the dot product between the queries and the passages, and then they will output the similar passages with the queries. So this is how the dense retrieval worked. So the questions, which is the queries and the passages, will separately encoded or tokenized into low dimensional dense representation with the BERT-based model. And at the indexing time, the passage representation are computed and then stored in the index, and then the passages will be embedded into the maps. So, but for the BERT re-ranker, it used the cross encoder, but the difference is that the cross encoder model that doesn't produce vector embedding for the data, but use a classification mechanism for data pairs instead, and such as two sentence will output a value between 1 and 0 and 1 in order to indicate the similarity between the query and the related passages. And so this is the introduction, and in our project we will have 4 tasks. The first one is reproduce the original pipelines, and then we compare the typo word training sparse retriever such as the BM25 with the typo aware version of BM25, and see if there are any improvement between these two. And then the third task is an investigation on the multilingual dataset for the typo aware dense retriever. And lastly, we apply the training on the state-of-art dense retriever, which is called task aware, and see if whether there are any improvement on this kind of dense retriever. So firstly, to reproduce the pipelines, So there are three objectives. The first one is to see if there are any. So the first objective and the third one is can be combined as with or without the typo-aware training. Is there any improvement between these two? And the second one is, are there any differences in affection between different typos of queries? So the typos are, there are 5 types of typos we used in the original pipelines. So when we tokenize the queries, we randomly, like 50-50% chance to input these typos into the queries, and in order to train them to be typo-aware dense retrievers. And these are the results that that I got from the algorithm, from the dense retrievers, with or without the typos, and we can see the significant improvement under the typo queries situation. And also for the second task, we didn't see that obvious difference between the typo-aware sparse retrievers and also without the typo-aware retrievers. So for the third task, I did investigation on the multilingual task, which is called Mr. Tidy. And on this data set, there are 11 different types of languages of data set. And we can see that there are query ID and query that we can use in order to train, evaluate, and also test it with the positive passages and negative passages. So these are really similar with the Markov dataset that we used in the original pipelines. So we just maybe apply I applied 3 or 4 different languages dataset rather than English in this case, in order to see the differences between or any found in this kind of data set. So according to the research paper on this link, and it posts a similar result as mine. So without the typo-aware dense retriever, we can see this is the sparse retriever benchmark, which is the BM25 benchmark, except the BM25 except the dense retriever for the English language. The others are all lower than the BM25 BM25's performance. So and also with the typo-aware training, it's maybe also in the similar trends. So lastly, I applied the typo-aware training on this state-of-art dense retriever, which is called task-aware dense retriever, as I mentioned at the beginning. So before the training, we need to know what's the difference between the dance retriever that we used in the original pipelines and the dance retriever that used in this article. So in this article, the dance retriever, they used shared transformer block, but in our original pipelines, the transformer block are independent for the queries and passages, but in this case, they just share the blocks. And also it adds some specialized transformer block. And in this block, they also add FFN sublayers for the queries and the passages in order to in parallel. So each of them have their own set of parameters, and the router is used to choose among these expert FFN sublayers. So I didn't get the results yet, but because my credit card is expired and my main project is has done on the Google Colab, and they only have limited compute unit, so I need to purchase more of them, but my Visa card is expired, so I need to wait my new Visa card in order to continue my research, but it won't be long, and I will add the results in my report essay. So that's all for my presentation. Thanks for watching.